we begin these notes, you should be having your notes open where you have this written down. You have your trig identities, your reciprocal, and you have the different strategies that we talked about in the notes. All right, here we go. We're going to be starting with this number 1. So on the left side right here, we're going to be doing examples, and I want you to try the problems on the right. Strategy 1 is called rewriting into sines and cosines. This numerator right here, sin x, is already in sine, so that's fine. But I look at tan x. Tan x is not in sine or in cosine. So what I'm going to do is, using my notes, I'm going to look. So tangent is equivalent to sine over cosine. So I'm going to rewrite this tangent right here. I'm going to highlight it in green. That's going to become sine x over cosine x. So remember, whenever you have a fraction in your denominator position, what you're going to do is you're going to take that fraction, flip it, and multiply. All right, so now we're going to be using our canceling skills. I have a sine x on top. This is actually in the numerator position. And I have a sine x at the bottom. What we do now is cancel out these two. You can always cancel out the tops and bottoms. When these cancel out, what you're left over with on top is just cosine x. That is it. So now, this sample right here, I want you to try it on your own. Again, it's very similar if you follow what I did and how I used my notes. You're going to be doing this on your own and checking in later. Here's strategy 1 again. We're doing another strategy 1. Again, we're focusing on converting everything either to sines and cosines. First step, I'm going to look right here. This is already in cosine, so this is perfect. This is fine. Let's move on. Secant x is not either in a sine or cosine format. So what I'm going to do is I'm going to look at my notes. I'm going to find secant. It's equivalent to 1 over cosine. So what I'm going to do is this secant x, I'm going to rewrite it as 1 over cosine. Again, we're going to be using our canceling techniques here. Cosine is in the top position, and there's a cosine at the bottom. What that means is when we're multiplying these, we can cancel. So this cosine right here cancels with this cosine. What's left over with on top is just 1. Again, you're going to be trying this problem on your own, using what I just did right here and how I'm using my notes. All right, again, this is using strategy 1. Looking back at your notes, this strategy is called rewriting into sines and cosines. So here we have a long strand that's multiplied all together. Sine x, cosine x, great. Cotangent x, this is not rewritten in sines or cosine. So what I have to do is this cotangent, I'm going to look back at my notes. Cotangent is going to be rewritten as cosine over sine. So this will be rewritten. Tangent is also not in sines or cosine, so what I'm going to do is I have to rewrite that as sine over cosine. So that's my next step right there. Those things highlighted, they're going to be rewritten using my key that's found in my notes. Now we're going to be canceling out items. So tops and bottoms cancel. So this sine can cancel with this bottom sign. This cosine that's on top can cancel with this cosine at the bottom. Or you could have canceled out this top sine with this bottom sine and this top cosine with this bottom cosine. But in the end, either way how you do this, you're still going to be left over with just sine x and times cosine x. Because this cancels with this and this top sine canceled with this sine. This right here, you can just rewrite it like this. These two formats are equivalent, but do make sure you write out your x's or a variable. Now over here, you're going to try this on your own using what we just did. Now we're moving on to strategy 2, which is basically factoring and simplifying. Again, this is in your notes. So in this technique, we've got to factor out a common term. There are 10 signs right here, and there's 8 signs right here. The common maximum amount of signs that I can factor out is 8 signs. I factor out 8 signs. Because I took out 8 from 10, I'm left over with 2 signs. Because I took out this whole sign to the 8x, I'm just left over with cosine squared x. Awesome. Now, looking back at my notes where I wrote down my 3 trig identities, I'm going to be using this common identity, which is cosine squared plus sine squared equals 1. Sine squared plus cosine squared is also equal to 1. Yes, it's written backwards, but it still means the same thing. Right here inside the parentheses, it's going to convert to 1. Sine to the 8x times 1 is just sine to the 8x, and you are done. You're going to take a look at this problem over here. You're going to do a similar technique. You're going to factor and simplify what's inside the parentheses. Strategy 2, we're still again focused on factoring and then simplifying. For this problem right here that I'm about to do, I need this for my notes. As you recall, I asked you to highlight the 2 important new identities in the last notes. From our notes, you should have that 1 minus cosine squared x is equal to sine squared x. This should either be circled or highlighted. Okay, so I'm going to be using this soon and you'll see why. So this strategy is again factoring and simplifying. I notice there's a tan x right here minus tan x cosine squared x. Because tan x is a common factor between these 2 terms, what I'm going to do is pull out tan x. What I'm left over with inside my parentheses is 1 minus cosine squared x. Well, if I look back at my notes, 1 minus cosine squared x is equivalent to sine squared x. So this right here is going to convert to sine squared x. Awesome, nothing else can cancel, so what I do is drop my parentheses and rewrite, and that's it. You're going to be trying out this problem on your own. Again, it's very similar. Alright, we're again on strategy 2, factoring and simplifying. Actually, strategy 2 is very reminiscent to this worksheet that you had, where I had you simplifying. Very, very reminiscent, as you can see. Very similar problems that you're asked to do here. So just saying, you want to make sure you do pull out that resource to remind yourself how we've done these, but here we go. So in this, again, we're factoring and simplifying what's inside the parentheses. For this right here, we're going to be ignoring the plus 5. We're just going to group these first 2 terms because I see a 7 here and a 7 here. What I'm going to do is factor out that 7 in a second after I did my grouping. Factor out the 7. What I'm left over with is just 1 plus tangent squared. The plus 5 stays on the outside. 1 plus tangent squared, now if I look back at my 3 trig identities, is equal to secant squared. This right here is going to become secant squared. I think that's all I can do. Drop my parentheses and I'm done. This right here, number 6, you're going to be doing on your own, very similar. And you're again going to be finding out which identity this matches with. Let us move on to strategy 3. Strategy 3 is called the common denominator technique. This technique you'll want to always have in your notes to remind yourself, hey, the goal is to get a common denominator. Okay, so step 1. In order to have a common denominator and to add these 2 terms, what I'm going to do is put this sine x over 1. In order to get this common denominator of sine x so that I can add these 2 fractions, I'm going to multiply this fraction right here, top and bottom, by sine x. Alright, sine x times sine x is going to give me sine squared x. 1 times sine is just sine x. Remember, the goal is to get a common denominator. Our denominators are now the same, so what I'm going to do is combine these numerators into 1. Awesome. Here is where my 3 trig identities come up. Cosine squared plus sine squared we all know is equal to 1. So I'm going to rewrite this top portion as 1. Lastly, you want to go ahead and look at your notes and see that 1 over sine x is actually equal to cosecant x. And basically, you are done. Number 7 is going to be very similar. Please follow the same steps and the same ideas that I used here. Common denominator strategy. Again, we're looking at strategy 3, which is the common denominator technique. from your notes, in this one, you want to make sure you highlight or circle the fact that 1 minus sine squared x is equal to cosine squared x. Before I do my common denominator technique, what I gotta do is convert these to sines and cosines. So that's what I'm gonna do first. Secant x, and it's not showing up here, but you should see that little box where it tells me what secant x is. Secant x is defined as 1 over cosine. My tangent x, I would look at my notes and see that it's equal to sine x over cosine x. So that's my first step, is I rewrote this one and I rewrote this one. Okay, now that I've rewritten them, I'm going to go ahead and multiply these out. Sine x times 1 is just going to give me sine x over cosine x. Sine squared x times another sine is going to give me sine to the third x and then all over cosine. That's what's going to happen in the next step. Awesome. And you know what's cool about this problem is that we did not have to force these two to have a common denominator. They already ended up having cosine x as their common denominator. But okay, now that the denominators are already the same, let's go ahead and combine the numerators. The numerator is going to become sine x minus sine to the third x, all over 1 cosine x. Okay, what I do next is, okay, I combined my fractions. That's the common denominator technique. This is strategy 3, but I'm not done yet. I could simplify this further. There's a sine here, and there's 3 sines here. How about if in this numerator part, I factor out 1 sine? If I do that, I'm left over with 1 minus sine squared x on top. Well, looking back at my notes, 1 minus sine squared x is equal to cosine squared x. This part right here is going to become cosine squared x. Awesome. Now, what I can do is there's 2 cosines on top, 1 cosine at the bottom. We could go ahead and cancel one of those. So since I canceled 1 cosine from here and the cosine from the bottom, what I'm left over with on top is sine x times cosine x. And that is it. You are done with this problem. Number 8, again, is going to be very similar. Follow the same steps that I've done and try to reach a small answer just like how I did. Instead of this large thing right here, you get this nice little concise identity. Let's all move on now to strategy 4. Strategy 4 is the split the fraction technique. If you look at your notes, you should follow what it looks like when I split a fraction. But I'm going to go ahead and show you right here. Your notes are gold, so you make sure you gotta look at your notes and try to attempt these to the best of your ability. Alright, so splitting the fraction technique means because these two are divided by the same fraction, what we're going to do is split them. This is kind of like opposite strategy 3. Strategy 3, we simplify by combining into one fraction, but strategy 4, you simplify by breaking up the fraction. Usually I'll be telling you which strategy to use, so pay attention to that. Okay, so this is how I broke up this fraction. Cosine divided by cosine is going to give me 1. Sine over cosine, well, let's go ahead and look back at my notes. Is sine over cosine equal to anything? Yes, it is. It's equal to tangent. This part right here is going to become tangent x, and you are done. This is your answer. We can't simplify this any further. Go ahead and try this one on your own. Here is the last segment of strategy 4, which is called the splitting fractions technique. Again, I'm going to split my fraction. Sine x divided by sine x is 1. This right here became 1, but this tangent right here, because it was not in sines and cosines, I went ahead and also rewrote it. And again, this is using my notes. Okay, what I'm going to do next is, okay, so this became 1, so this is fully simplified, but this right here, it looks like a big mess. I got to finish simplifying this side. Sine x, what I'm going to do is rewrite it as over 1, because what I'm going to be doing is using the flip and multiply rule. Alright, so sine x over cosine divided by sine x over 1. Whenever you're dividing by a fraction in your denominator position, you're going to be flipping the denominator, okay? You don't flip this top part. So only this one is going to flip and you'll multiply. Oops. There you go. So see how this flipped and now we're multiplying. Alright, so we got to remember our canceling techniques. Tops and bottoms cancel. So sin x on top cancels with the sin x from the bottom. So what you're left over with on top over here is a 1 and a cosine at the bottom. Awesome, we're almost done. Let's look back at our identities to see if 1 over cosine is equal to anything. Yes, it is. 1 over cosine is equal to secant x. So basically this is 1 minus this part is secant x. And you are done. Oh, no, that's it. You're done. You should not have an equals right here. That's it. Hopefully this video was helpful. I look forward to seeing your attempts on the right side of this page. Remember, you must come to office hours if you are stuck. I look forward to seeing you there, and good luck.